Now, what we're covering today is special factors, special sets of factors, okay? So these here, when we see a set of factors that work in a particular way, so our first one is the difference of two perfect squares, it'll work like this every single time. Now, I don't want you to write these down, I just mainly want you to look at them. The other type that we have is a squared minus 2ab plus b squared, and a squared plus 2ab plus b squared. These are the other two types of perfect, or not perfect, but other types of special factors, because these two here work out to be a minus b squared, and this one here works out to be a plus b squared. Whatever the factors are, they're going to be the exact same, so we square them. However, the bottom two, the two that I just wrote up there, the sum and difference of squares, these two down here, the methods that we went over last week for chapter 3.1, part 1, 2, and 3, work just fine for this here. For these bottom two here, I feel it takes more time and effort to try to see and work it out so that we see what the values of A and B are to set this up than it would to just factor it like we did last week. So the methods where we did two sets of parentheses, found the sign, factors of A, factors of B. So doing it like last week where we did all those steps, it's going to be easier to do that than to try to work this out for this one here and this one here. It's going to just take longer. It's going to take longer to find those that way than it would be to just do our steps. So I don't look at these two too much at all because it works out just fine. Now, the difference of perfect squares is different. It actually works faster with the trick. Because what we're saying is that the first term, whatever it is, numbers and variables, is a perfect square. It's something that we can say is multiplied by itself. B is the same thing. If I have two terms being subtracted that are perfect squares, then I can rewrite it as a plus b times a minus b. So their example is this here, x squared minus 9. Well, x squared is a perfect square, yes? X times x. Well, 9 is what? 3 times 3. 3 times 3. So I can rewrite it as x squared minus 3 squared, which would be x plus 3 times x minus 3. And we use this form here to solve. So we'll look at some examples of this here. Now, one of the first clues when we look at a problem to determine, is it a difference of perfect squares? Well, one of them is it a difference? Do we have two terms being subtracted? Well, here, yes, don't we? Now, we can't have a middle term. I can't have, for this here, since the variable is x, I can't have a term with just x, because I have x squared and I have 25. I cannot have a middle term. And that's fine. Now we also need to see, is the first term a perfect square? Is something times itself? Can I take the square root of the first term? First term is x squared. What's the square root of x squared? Can I take the square root of 25? So is this a difference of perfect squares? Yeah, because I do have two things being subtracted. I don't have a middle term. X squared is a perfect square. 25 is a perfect square, yes? Now we're modeling this off of a squared minus b squared is equal to a plus b times a minus b. Well, in our case here, what is the value of a? A squared was the first one, so a is just x, yes? So in place of a, I will put x. So what's b squared? Well, b squared was 25, yes? What's the value of b? 5, yes? So I plug it in for b, 5 and those are the factors. That's all we have to do for this here. That's all that's required for this here, factoring it.
I was thinking it was going to be long, drawn out.
But that's it. Yes? Do y'all think this is a little bit faster than factoring, the way we did it last week? Yes. That's why I cover these here. These here are a little bit easier to see how it works out. Now, would it be wrong to do these the exact same way we did them last week? No. Because if you remember last week, we did cover, let's see here, I believe it was this problem here, 12x squared minus 75, where we factored out the 3 and then did the factors. Yeah, these here, I can use the same steps, doing this 2 sets of parentheses with 3 spaces, finding the sign, factors of the first term, factors of the third, and work it out that way. And I'll still get down to this here. It will still give me to the answer. But this here, these steps we do here, if it is a difference of perfect squares, kind of gives us a shortcut to finding it. So let's look at this one here. So I don't have a middle term and I have subtraction, yes? So most likely, well, all of these here are going to be a difference of perfect squares, is we have this difference, yes? Now we need to determine, are the 2 terms, the first term and the last term, perfect squares? Well, square root of 4z squared. The square root of 4 is 2. Square root of z is just z. Now, if you were wanting to plug this in, you can't plug z squared into the calculator. The calculator has to have a value for any variable plugged in. So we can't do that. But I can always take the square root of 4. Because the calculator will do those just fine. Square root of a number, it'll tell me, is this perfect square? So square root of 4 is 2. And then the square root of z squared, we can kind of do that by hand since the index of this is 2. 2 and 2 will simplify to 1. Now, what's the square root of 1? 1. So are both of these perfect squares? Yeah. So what are we basing this off of? It's our a squared minus b squared, which turns into a plus b times a minus b. So looking at this here, what's the value of a? Because a squared was our 4z squared, that's where it matched up. Well, a is just 2z. And the value of b is? Any questions on this here? Any questions on anything we've done so far? We good with this here? Why don't y'all give this one a try, and then I'll give you a few minutes here. So looking at this here, we do have a difference of perfect squares. Because x squared would be just... Would be this here. Now, the only way we can really simplify 8 is if there's something that we could factor out or some way to simplify it. Okay. But here, there's no way to simplify any of it, so this here is just our answer.
So will we see these areas on the test where we would have to factor?
We can, yes.
Okay.
So are there any questions on this one here before we move on? So let's see here. Let's do... I'm going to add this one in. So you can put it at the bottom of the page. Add that one to the bottom of the page. 8x squared minus 64. So we do have subtraction, yes?
When you take away, so you're trying to get x squared, so you take away 8.
Well, let's see what 8x squared, because what's the square root of 64? All right. or 2.8 or 2 square root of 2. 8 is not a perfect square, is it? No. But this is still a difference of perfect squares. So, because what you notice, and what we should notice is, so there is a greatest common factor between these two, yes? So, let's see here. 8 would work for 4. That doesn't need to be 64. What does that need to be? It does. Because we could factor out 8. I want to try factoring out 4. And let's see what we're left with. We have 4x squared minus 4 goes into 16 once, and then 16, yes? Actually, let's take it all the way down. Let's actually do 8. Which would really leave us with x squared minus what? Could that be 8?
But
X squared minus 8 doesn't work, does it? Because we already know 8's not a prime factor. 4 would. Somehow, it's kind of magical this way here. Because that would leave us with what? Actually, I take that back. This isn't going to be a perfect square. No. This would, this needed to be 12. Yep, that's what I get with trying to make one up off the top of my head. No, it just needs to be 12. So mark that out. That's what I wanted it to be. I wanted to have a greatest common factor of 4, which would leave us with 4x squared minus 16, which we could technically factor that out. Not 4, gosh dang it. Yeah, that'd be 3, which wouldn't work, would it? Nope. Okay. I want y'all to just, it is a Monday for sure. Just, no, just, let's see here. Just watch this one here. So I just watched this one that I'm about to do, because if you want to write it down, you can. This one I know will work. I'm just going to try to keep it as simple as possible. 2, we cannot take the square root of. So if I factor it out, we get this here. This time, x squared is a perfect square. And 16 would be 4 and 4. So it is possible to do it this way. But if you have trouble kind of seeing it, especially if you're looking at the first one and saying, okay, neither one of these is a perfect square, but I do have a greatest common factor of 2, we can go back into the old method and factor one out. And then I could check to see, is it a perfect square? If it is, then we can do the perfect square method. Say we didn't notice it, we can go back to this way here. Since the constant term is negative, the signs are factors of the first term would be x and then we'd have 4 and 4 would be the only set of factors that would work. So it is possible still to do the 2 sets of parentheses. Well, it's not just a 2. It works in other cases. This is just the easiest one I can come up with off the top of my head. But it still works. And sometimes it requires greatest common factor, or we can just go back to the factoring methods. Okay? Any questions on these here, now that I've thoroughly confused you with that one? So this is a difference, yes? Now we need to see, is it a difference of perfect squares? So can we take the square root of 100, which would be 10? So the first term and last term are perfect squares, yes? So really we're modeling this after a squared minus b squared, which is a plus b times a minus b. Now what's the value of a?
Great. Question.
Yes.
So after is negative, we can deal with the 100 being positive.
So the 100 would be a. Or a squared, and a would be 10. What's the value of b? M.
So I got it right.
I was talking about the side.
Yeah.
Because that last one,
Right, we could rewrite it.
I was just wondering.
This here.
Okay.
And our answer would be negative m plus 10 times m minus 10.
Okay. I was just confused where positive and you usually call it with negative.
Either one of these is the correct answer. Because of our difference of perfect squares, it actually works out. It doesn't matter how it's set up. It'll still work.
Will big math have you take that?
If it doesn't, let me know and I can fix it. But it should.
In case, because I know it's really picky about what it gets.
It should. These should be the same thing.
Okay.
Questions on this here? Yes.
If we were to write a 10 minus m and then 10 plus m, would that still?
So leave out the negative.
No, I mean switch it. No, I was meaning on the side, the purple side. If we would flip the sides, negative this first. But that,
It doesn't matter. Multiplication is commutative. We can multiply any two things in any order. Yep. Any other questions? Do we feel comfortable with these here? Yes? Do we need to see another example of one of them? Let's look at this one. So we have two different things and they're being subtracted. Now we need to see, are they perfect squares? 16h squared. So if I can take the square root of it, 16h squared. So these are perfect squares, yes?
Yep.
So really I'm just taking the square root of it. So square root of 16 is 4, square root of h squared is h. And the square root of 49 is 7. Now, a squared was our 16h squared, yes? I haven't really been stating that, but that's what it is. And when we square root it, we find the value of a is 4h. So where a is, we can plug in 4h and 4h. Well, b squared was our 49, so the value of b was, and we plug it in. And that's it.
So I feel like next set of things you're like really cheating, especially the evaluating a number of stuff.
So any questions on this here? We good with this here? So this is the one that kind of looks scary, yes? Well, we have two things squared, don't we? Well, our formula that we just stated, a squared minus b squared, is equal to a plus b times a minus b, yes? So 54 squared minus 48 squared, well, 54 is our a, 48 is our b, yes? If I wanted to solve this, I could say 54 plus 48 times 54 minus 48, because I could rewrite this, which makes it a little bit easier to solve, yes? Because we can add these two together, which would be 2 carry the 1, which would be 102. 54 minus 48 would be 6. And lastly, we can multiply. 6 times 2 is 2, carry the 1. 6 times 1 would be 0 plus 1. And we should get 612. Try plugging that into a calculator. 54 squared minus 48 squared. Yeah. 54 squared minus 48 squared.
So realize you got earlier, anything else?
You got 612, didn't you?
Yeah.
Yeah, that's it. That's the answer.
So you could just plug in straight as long as there's no variable.
Yep. Since there's no variables on these here, we're just evaluating for the number. We can plug it into a calculator. So, I mean, we can do the exact same thing here. We can do 68 squared, or 68 squared minus 62 squared in the calculator, and it'll tell us exactly what the answer is. Yeah. So what would be the answer for this here? And that's it. That's all we have to do for this here. Now, the other method, the way that we did the first one, is a way that you can solve these without a calculator. It's a way to solve them without using a calculator. Any questions on this here?